In this video, I'll be discussing how we can balance a redox equation in an acidic environment. This is for the honors chemistry course, and it is 2 out of 3 of our mini-series. Looking at this question, it says, in an acidic solution, and that will be your clear indicator in any question that these are the steps you're about to do. In an acidic solution, you have dichromate ions mixed with HNO2 ions, and they are producing chromium ions and nitrate ions. So the very first thing you have to do is separate the half reactions. We're noticing in our first half reaction, we have our dichromate breaking down and composing itself into chromium ions. In our second reaction, we notice our HNO2 is composing itself now into nitrate ions. The second thing is you have to balance out all of the elements except for hydrogens or oxygens. So if you look across the first row, you'll notice we have to put a 2 here. You have to have 2 moles of our chromate ions. However, in the bottom row, we don't have to change anything because we have the same amount of nitrogens on both sides. The second thing we have to do is we have to add water molecules to physically balance out the oxygens. In our first reaction, we notice that we have 7 oxygens, so therefore we need 7 water molecules as a product. In our second reaction, we notice we are short 1 oxygen on our reactant side, so we add 1 mole of water to balance out the oxygens. The fourth step is to add protons to balance the hydrogens, which are always found in the water. So, if we notice in the first line, you have 14 hydrogens in water. So therefore you have to add 14 protons to your reactants. In the second equation, you notice you have 1, 2, 3 hydrogens, 1 found in the starting acid and 2 found in the water. So therefore you need to add 3 protons to your products. We notice in the first compound of Cr2O7 with a -2 charge, every chromium has a +6 charge. We notice on the product side, your 2 moles of chromium ions, they have a +3 charge. That means chromium gained 3 electrons. In the bottom, in our acid, we notice nitrogen should have a +3 charge, while the nitrogen in our nitrate has a +5 charge. That means nitrogen is going to be losing 2 electrons. We figure out how many electrons we had to add, and we plug them into the form like so, which is in orange. The sixth step is now to figure out the least common multiple between the electrons to make the electrons the same. So you notice in the first reaction we have 6 electrons, in the second reaction we have 2. We have to find the LCM. The LCM for these guys is going to be 6, so we have to multiply the bottom row all by 3. That way we can make the 2 electrons become 6. Everything else in that bottom row is also being multiplied by 3. So again, this is the reaction that we haven't touched, and your new reaction for the bottom should say that you have this. The 7th step is to combine the half reactions, just like we did in the neutral solutions. After you do that, you have to cancel out all the common species. So again, if you strategically write these 2 half reactions with the yield arrows right on top of each other, you can then start to cancel out all the common species and the electrons. So let's start with the electrons. You notice we have 6 on top, 6 on the bottom, so they cancel out. The next thing we go over is look at the waters. In our top reaction, you have 7 waters, and in your bottom reaction, you have 3. When we cancel these out, the 3 is going to completely disappear, and the 7 will come down to a 4, and that will represent 4 water molecules. The last thing we have to do is do the same thing, the subtraction rule, with the protons. In our top reaction, we have 14. In our bottom reaction, we have 9. So we're taking those 9, canceling them out, and we're doing 14 minus 9. So our final reaction shows that we should have 3 moles of HNO2 with 5 protons plus a dichromate ion, which will be producing 3 nitrate ions with 2 chromium ions and 4 water molecules.